Good afternoon or good morning. My name is Jose Fuentes, and I will be your host during this 1-hour webinar. So the content for today's webinar is the following. I will start by a brief introduction about the Reuse company and about Requirements Quality Suite, the tools and techniques that make all this possible. Then I will have a brief overview of what is the tendering process and the main challenges in a tendering process. Not in too much detail, because probably you know more than me about this topic. And the following topic is just to describe how a knowledge-based approach using semantic tools and natural language processing tools can help both buyer and bidder during this tendering process. And finally, we'll have a live demo and some question answering section. So, as I said, Jose Fuentes, Chief Operating Officer of the Reuse company. Here you have my contact details. I work for the Reuse company, as I said, and where the main three pillars of our technology are also aligned with the acronym TRC for the Reuse company, because our three main pillars are traceability, reuse, and C or Q in English. In Spanish, quality is spelled with a C, and in English with Q. So TRC, TRQ for traceability, retrieval, and reuse, and quality. And all this is possible, as I said, thanks to a set of ontologies and asset management to analyze in an automatic way every different kind of work product created during our projects, mainly dealing with requirements, which are our key topic today, but also dealing with now in the next version of our tools, we are focusing more and more on models and test cases and other work products. During this webinar, I would like to thank ULMA people. ULMA is our business partner here in Spain, and they have helped us collecting information and preparing the material that will be presented and the demos that will be presented today. ULMA is based on Spain, as I said, and is focused on safety critical industries such as railway, medical, energy, automotive, and industrial in general, providing consultancy for systems engineering, software engineering, hardware, and programmable logic. And last part of the introduction is very briefly to introduce the three main tools in Requirements Quality Suite. These three tools are Requirements Quality Analyzer, the tool for quality people in the organizations and the teams. Requirements AlphaUntil, tool for the authors, and Knowledge Manager, just to deal with the managing of dictionaries, vocabularies, patterns, ontologies, and so on and so forth. So let's get right to the point, describing very briefly, as I said, what is the tendering process in organizations. So normally this starts with a buyer issuing or providing a document for the public tender, where different suppliers or bidders attend to this bid. The idea behind this, when you as a company attend one of these bidding process, the idea is to reduce risks. So, and for us, the key is software and system reuse to reduce the risks in your projects. So, what can be reused? Normally, everything: equipment, requirements, tests, code, documentation, blueprints. Everything can be reused. So, as the more information you reuse, or the more work products you reuse in your projects, the more you reduce the risks in your projects. So normally the process, as far as we see this process from the technical point of view, start with as a tender, with parsing the public tender document just by breaking down the document into manageable requirements document, and hopefully trying to do it in an automatic way, so that all this information that is normally received in a kind of word processor document, PDF or Microsoft Word, could be hopefully copied and pasted into our requirements management tools, doors or PTC integrity or whatever. Then, so for this task 1, T1, I will show you some tools and techniques within Requirements Quality Suite to help you in this parsing of the documents. Then the second point is, the second activity is to cluster all these requirements, just to allocate requirements to one of your teams or departments in your organization. This process is followed by the detection of poor quality requirements, detection of inconsistencies in your requirements, mistakes, incoherences, and so on and so forth, so that these teams could somehow estimate the development effort, time, and cost for attending the bid. Then, as I said, it is key in order to reduce the risk of your projects. It is key to try to find the gap and bridge the gap between what you as a supplier already know and already have in your systems for existing projects, and what is coming with the tender, right? So the idea is, as I said, identifying what are the issues requested in the tender that has been already addressed by your company, so that you can promote reuse strategies for all these assets, and of course identify the gaps. What are the points requested in the tender that are not fully covered, or you don't have enough skills in your organization, or the other way around? What are the key topics that you master in your organization and somehow are not covered in the tender, so that you can react in the proper way to this tender as well. So having said that, as the context for this kind of tendering process, now I would like to introduce some semantic techniques based on knowledge management, just to have tools helping us during this process. So first, the idea of knowledge-centric systems engineering or knowledge-centric approach starts with our 4 key issues. First is the system knowledge repository, where all the work products will be allocated and will be stored, followed by the system knowledge base, which is a kind of knowledge representation of the business domain that we are addressing for this particular project. Then, as you will see, especially during the demo, requirements patterns are also key to the success of this approach. I will explain later in a minute all these 4 items, and then our semantic indexing process that will be described in the following slides. So first, as I said, the knowledge base is basically, if we want a tool to perform some sort of activities during this process, the more information we provide to these tools, the more accurate the answer of the tool will be, right? So in our approach, as you probably know, ontologies are key to represent the knowledge that we provide to these kind of tools. And we like always to represent these ontologies by this kind of onion chart, including these 5 layers of information and knowledge. First, vocabulary or dictionaries, where we store common terms, forbidden terms, to be analyzed during the quality checking of the requirements, domain-specific terms or other common terms in bidding, in tenders. Then, with the plain list of terms elaborated in the dictionary or vocabulary, during the conceptual modelization of the system, what is normally done is a clustering or linking of all the items, all the dictionary entries from the previous layer. So that now this is no longer a plain list of keywords, but it is now rather a set of different clusters grouping together similar concepts by different criteria, or linking together the concepts that are semantically linked or has something in common between them. Then, as I said, the following block here are patterns and pattern formalization. This is what allows us allows the tools to understand the real meaning behind a textual requirement by means of first matching these textual requirements with requirements pattern, and using the pattern formalization schema. The idea is to extract some sort of knowledge maps out of every of the different requirements that are analyzed. And then finally, we provide this inference rule layer where we can provide advanced reasoning for our systems. In the presentation the presentation on the demo that you will see today, there is no inference rules applied. However, in the next version of our tool, which is expected by the end of this year, where we are improving a lot in this point, providing plenty of different rules applying inference and logic towards the quality and consistency and reuse of work products all along the systems engineering life cycle. Then first, as I said, our key topic are patterns. Pattern is just, as you probably know, a kind of a sequence of different blocks, a kind of Lego building, where you describe what is the grammar, the content for a requirement. So this in the screen is one of the classical patterns described in plenty of different IEEE standards, saying that for this kind of requirement, I expect when keyword and then a condition for a subject to perform a kind of action over an object within a time constraint. So this is the structure for one of the different types of requirements. And as you will see today during the demo stage of this presentation, you will see plenty of different patterns working together towards the success of this demo. These patterns are useful for the identification of requirements, for identification of vocabulary and extracting this vocabulary from the tendering documents, for requirements matching, for requirements classification and clustering, and also for checking the quality of the requirements, as you already know in our tools. So this is just an example of the 5 layers, in this case for aerospace industry, where in the first layer we have different terms, all of them belonging to this industry. Then in the system conceptual model or thesaurus model, what we do is we cluster together or we link together the concepts in the previous layer, providing additional business-specific knowledge. Then this is just another example of a pattern, and this is the formalization for this pattern, just to represent this requirement in terms of a semantic graph. And then finally, as I said, an inference rule example here, just to make sure that the temperature that we find in the requirements is within the limits that we are expecting. In this case, it is not. So this is the reason for this red cross here, right? Regarding the indexing process, I will use this indexing process a lot during this demo, but of course you don't have to know or you don't have to understand all the different stages. So I just keep these stages in this slide, so I will not describe the steps one after the other. But after following all this indexing process, the idea is to be capable of first analyzing a textual requirement, such as the one you can see now on the screen. When ice is detected, the car also an ice icon in less than 0.5 seconds. And by first matching this textual requirement with the pattern that I previously presented in the previous slide, the idea is to be capable of having some sort of semantic formalization as the output for this indexing process, so that in the end what we get is this kind of semantic graph. And this is the input for all the, let's say, for all the quality analysis and all the matching and clustering that you will see today, right? So what the tool is doing, of course, you are not going to see this, the intermediate output for this, but what we are doing is taking all the bunch of different natural language requirements that I will present in a textual document. And before we proceed to any kind of quality checking or matching or clustering, the tool will proceed with the identification of the semantic graph. This is just an example, right? So, how can all these techniques be applied to a tendering process? Let me just provide some few slides before I jump into the live demo. So first is, for those of you who already know, our approach is based on knowledge management. The idea is to have a consistent vocabulary between all the parties involved in the tendering process. So if we don't manage to use consistent vocabulary, then the chances to fail in our project are huge, right? So the idea is first to identify the vocabulary which is already described in the glossaries and an acronym lists in the tendering document, but also be capable of extracting, as you will see in the live demo, extracting knowledge and content from this document in an automatic way by using requirements quality analyzer in this case, right? Second step, as I said, is okay, why not trying to analyze the input documents or the documents for the tender in order to identify what are the requirements within this document. In some cases, hopefully, the input for you as a supplier in this tender, as a bidder, what you get is a well-structured document where you can very quickly identify requirements because of the structure of the document. However, in many of the cases, the documents are not so well structured as it should be. So the idea is we are offering a set of tools now in the requirements authoring tool, in our tool requirements authoring, just to, by means of the identification of patterns, requirements patterns, such as the three examples that you cannot see in the slide, we can very easily identify what paragraphs in your document are requirements, which are not, and injecting all these requirements into the requirements management tool that you could be using for the entire process. DOORS, PTC Integrity, JAMA, or just Recif or Excel files, right? Then once we are sharing a common vocabulary between buyer and suppliers, and we have extracted the requirements from the documents, the next step is in our approach to check the quality of our requirements. You know that this part will be covered very quickly in the demo and also in the slides. Mainly because this is the key topic for us, and you know that we have plenty of materials, presentations, demos, and everything in our website, so that you can use all this material when you want. But briefly speaking, our approach for requirements quality is to address this quality using three main dimensions for requirements quality. First is correctness, to analyze the quality for individual requirements, while we also address consistency and completeness just to analyze quality for sets of requirements. It could be a complete or a full document, or it could even be a set of different documents. All these quality rules could be following whatever best practices or requirements writing guide that you can have in your organization, or you can use classical Inclusive guide for Latin requirements or whatever the guide. But please be aware that normally all these guidelines that you can find should be tailored to the specific needs in your project, in your team, or in your company, right? Then the following technique that will be shown is a kind of matching between the needs coming from the buyer and the requirements of the systems that you as a supplier already have in your organization. So normally when you attend one of these tendering processes is because you have already built or you have already dealt with these kind of systems. So you have a system already built in your organization, and you have the requirements for the system. So as I mentioned in the introduction for this webinar, the idea is to match the needs coming from the buyer with the system requirements that you already have for your systems. So here in this slide, you can see two textual requirements. One is representing one of the needs coming from the buyer, while the second one is representing a system requirement from your systems. So the idea is to come up with a kind of matching between these two requirements by saying, okay, we can these two requirements, as you can see here, are using different structures, these requirements are using different keywords, but in the end, if you take a closer look to these two requirements, then you can feel that these two requirements are kind of meaning the same. So following the transformation that I was presenting before, we provide requirements criteria analyzer, our tool, to analyze these two requirements and come up with a common knowledge representation for these two, let's say, different requirements. And this is key for requirements reuse or for the matching between the needs and the requirements. But however, in order to make possible for the tool to come up with this with the same representation for the two requirements, we have, as I said at the beginning, we have to provide some knowledge in terms of system knowledge base. So this is why I'm showing the same onion chart again with the 5 layers. And here I am representing that in order to have these two requirements representing the same knowledge graph, then we have to train a little bit the tool, saying that, wow, yes, here you can find that there's an equivalence between target and hit. These two keywords are equivalent for this kind of systems. There is also a taxonomy saying that radar is a kind of electromagnetic sensor, which is a kind of electromagnetic device, which is a kind of system. And we have also find here a cluster linking together or clustering together different actions such as identify, discover, detect, and find. And by means of this cluster, we are training the tool, saying that these 4 actions are somehow similar in our industry or in our business domain. So by providing all this kind of information, we make it possible to analyze these two, let's say, different textual requirements and come up with the same representation, so that the tool now could identify these two requirements as very similar or the same requirement, right? Then, as I said, the following step after this matching of requirements is to allocate for those requirements that could not be matched between the need from the buyer and the requirement from our system. The idea is to know which is the team within our company, which are the person that should be addressing each of the different sections of the document or each of the different requirements in the document. So the idea is to, as I said, to cluster requirements based on different criteria. One of the criteria, as you can see here in this slide, is just by fitting into one of the different patterns that we can provide to the tool. As you will see in the live demo, in this slide I have created a small pattern just by using an entity, shall, have, and then a number, and then another entity. And this is just representing what the pattern, the format that all the structural requirements should have in the tendering documents. So just by clustering all the requirements that are following this specific grammar or format and showing or allocating all these needs into the specific team, right? So this is the idea. And of course, we can provide clustering just based on keywords or based on what in our technology we call semantic clusters, that are sets of different clusters, as you can see here below. All these different bubbles are representing, in this case, this is an action cluster. This is a system element cluster, including the terms vehicle, brake, and so on. Or this is acceleration cluster, including the keywords accelerate, decelerate, brake, and so on and so forth. Or this is the cluster to address speed by putting together verbs and measurement units and other keywords that could be addressing the topic of speed. So, and this can be also used for our automatic clustering of requirements, right? So as a conclusion, before I get into the live demo, there are a number of different activities and techniques that can be leveraged by using our semantic approach. The first one is core, is the key to us, which is knowledge management and having a common understanding shared between all the different parties involved in this tendering process, starting with shared vocabulary. Then remember requirements tagging and extraction by using patterns and by identifying all these requirements in an automatic way. Third, being capable of analyzing the quality of the requirements in both sides, in the side of the buyer and also in the side of the bidder. Then to identify gaps between what is described in the buyer's document and what we already have as a supplier, what we already have in our systems. Then identifying all this matching between what is coming from both sides, buyer and supplier, just to promote reuse activities. And finally, as I was presenting in the previous slide, just providing requirements clustering, just to streamline the tendering process by allocating all the requirements to a specific team group in our organization, right? So we can find, finally, in this final slide, we can find that we are providing help to both sides, the buyer on the one side and the bidder on the other side. For both of them, remember that the key is reduce risks. So for me, providing this kind of automatic tools and techniques to this tendering process is a means of reducing the risk in both sides. In the side of the buyer, of course, if you are capable of having a common understanding by sharing dictionaries and ontologies between all the different tenders, then you will, as I said, you will reduce the risk because all the suppliers will be understanding the same out of your document and will be understanding what you really meant. So the idea is to promote high quality tender documents from your side and reduce the overall costs. From the bidder side, it is pretty much the same. So the key is reducing risks by sharing this common understanding with the buyer, promoting and having high quality specs in your site, and by the clustering and linking of the requirements that I was presenting, and I will show you in the last demo, you will have more reuse in your projects and less reworks, what will end up in less expensive projects and, of course, reducing risks in the overall project, in the overall value chain for your project. So let me now go for a live demo. My intention is to have some minutes at the end of this webinar, just for you to have some questions. So please, if you have any questions so far, please write it down in the chatting box so that all these questions could be addressed after the live demo. Well, these are, here you can find, exit here. These are our tools. Some of you already know Requirements Quality Analyzer, Requirements Offering Tool, and Knowledge Manager. These are our three main tools. So let me address all the different activities that I were mentioning one after the other. First, of course, is, as I said, or having some sort of common understanding by sharing dictionaries and glossaries and all these kind of knowledge assets between the buyer and the tender. And the first way to address this could be as easy as just opening your document and checking for the acronyms or definition section. This is something that I have already done, and I have very quickly moved all this information from these documents into our tool Knowledge Manager. So if I open Knowledge Manager, then I have created a system knowledge base here, just representing a portion of the information coming from the buyer. In this case, as I said, just by copying and pasting information coming from the document. Let me open the RFP document that I have used for this demo. But very quickly, you will identify what are the acronyms and the definitions within this document. So what I have done is I have just exported. Let me look for it. So this is a very large document, so I will probably skip some of the steps because they are already done in the, for instance, the identification of definitions and so on has been already done. So what I have done is I have just copied and pasted all these into Knowledge Manager by using the import and export options of Knowledge Manager. It is pretty easy to come up with this with all these definitions in the ontology. So we already have these keywords in the ontology. This is easy, so I skip this process. So the second activity is once we are capable of identifying the requirements, we can extract what are the most common keywords as used in the requirements. Probably most of these keywords are not described in the acronyms and definition section of your document. So let me now go to requirements AlphaUntil, because this is the tool. Here you are. So this is the tool we use to extract requirements from a document. So this document, as I said, is pretty long. It is over 400 pages. So I have another version of this document which is shorter, just addressing one section of this document. So this is what I have done. I have just created this small document. Well, let's say small. It is over 100 pages, so it is not that small. And now I will use requirements AlphaUntil just by following some sort of patterns, extract requirements from the document. So the document is pretty well structured in this case. But however, I have elaborated a number of different patterns in KM. This is KM, Knowledge Manager. And I have elaborated a number of different patterns here in the pattern section of the tool, so that I can use these patterns for the extraction of requirements, right? So I have a group of different patterns. I call this requirements tagging. So these are the requirements that I have used. So I have created patterns such as I want to identify all the sentences in the document starting with a noun plus shall be plus design plus whatever, or noun plus shall plus an action, or noun plus shall be capable of plus an action, or something like shall have a number of other nouns, other entities, or shall be as, and then followed by a property. So the idea is that once you identify all these patterns, it is pretty quick in our requirements AlphaUntil just to point to this is the short version of the document, just with the technical section. So you just identify the document, you provide what is the set of patterns you want to use. In this case, as I said, it is for requirements tagging. So these are the patterns that I was showing before. And then now the tool is opening the Word document, identifying all the paragraphs in this document, and and the tool has very quickly identified over 1,000 requirements in the document. All these requirements are following the structure as described in this pattern. So the identification is pretty quick, and saving into doors is probably not as quick as the identification. So this is the first step. Then the second step, I have other modules, those modules where this information is already done, is already analyzed and already stored. So I can now go back to requirements AlphaUntil while they are to requirements quality analyzer, while the AlphaUntil is storing all these identified requirements into doors, right? I'm using doors for this demo today, right? So here I have the same modules, but instead of connecting to the auto tag, which is the one which is been written here, now I am connecting to another module. This one. This has all the requirements already extracted, right? So the following step is just to identify what are the most common keywords as used in this specification. Understanding or properly understanding all these keywords will allow us as a supplier to have a better answer to this tender, right? So I have this is RQA, Requirements Quality Analyzer, mostly used to check the quality of the requirements. But as some of you already know, we can use this quality analyzer just for other activities, such as, for instance, identifying what are the most common keywords in your requirements and in your documents, right? So this is why I have changed this time. It is not a quality baseline which I'm using here, but rather vocabulary extraction. So if I try to analyze the quality for this module, instead of just checking the quality, what the tool is going to do is just to identify what are the most common keywords in your spec, right? So it takes some seconds. This is, as you can see, a shorter version, just to have a quick analysis. If not, every of these analyses could last probably 2-3 minutes, and this is too much. So what I have done is very quickly we can identify what are the keywords that are used in this document that are not properly represented in our dictionary, so that we can have a common understanding of some of these keywords. Probably some, of course, this document is a railway document. Probably we have to say that the dictionaries are not fully addressing this business or this industry. So this is why you can find plenty of different keywords identified here that you can find that are, let's say, regular keywords, but are not part of the ontology. So here what you can find is also the connection. We sort by frequency, so here you can find the connection between these keywords and our knowledge manager. So again, it takes some minutes. I will not going to repeat this process, but it is very quick to take some of the keywords that you can find here and just copying and pasting all these keywords into our tool knowledge manager, just to be part of the dictionary, right? So more terms that we have identified is we would like to know what are the most common actions or verbs that are coming after shall or after a must or will or may. So you can find here what are the main actions. It is important to know that we as supplier and the buyer are both on the same page in terms of the actions, or in terms of which is the way we are naming all of our systems and subsystems. So these are all the names, including the keyword system. So now we know that in this small section of the document that I have analyzed, it is describing a power system or vehicle system or memory system or some other braking system. So these are the key systems that are being analyzed in this document. So we can have more new keywords identified in a very quick way, right? So once we have also identified the common vocabulary in our systems, then the idea now is to check what is the overall quality for the requirement document that we are analyzing. So in this case, I have prepared a kind of a small set of quality rules to analyze for this document. So this is these are the rules. Now I am applying the same rules to the same document, and if I click here and analyze the quality for my requirements, now for the first time I am just analyzing quality. I'm not trying to identify missing keywords or something similar. So this is the key of our tool, requirements quality analyzer. So this is what we normally do in our demos and in our presentations and webinars. So the tool is taking some seconds just to analyze these 300 requirements. Now I'm done. So you can see here what are the requirements with 3 stars, 2 stars, and 1 star. So the idea could be just to sort or focus on those requirements with poor quality that are the ones on the top. So just to have a quick summary of the defects that we have identified, we can say, for instance, that we have, that we have requirements with including pronouns, which is including pronouns is normally not a good practice when writing requirements or writing needs. So these are the requirements including pronouns, or these are the requirements including acronyms that are still not part of our dictionary. So most of these, the solution for this is just to put all these acronyms in our dictionary. But this is a way to understand if there are some missing acronyms in the input document, or what are the requirements that are mostly addressing the rationale and not the requirement itself, with special keywords here and there, or which are the requirements, so probably the requirements that are too long, or so here we can identify the number of requirements that are too long, in this case only 18, and we can see what is the average length and so on and so forth. So this is what we normally do. So I will not focus a lot on this quality checking, because this is the regular activity for our company. So I will jump into the following process, which is just the clustering of the requirements. So here we have all the requirements. Indeed, I understand that the previous process that I launched here, are already done. So I will take the information from all these over 1,000 requirements that have been now stored here. So I'm just closing requirements AlphaUntil, and I am refreshing. Sorry, this is requirements AlphaUntil, and I am refreshing the information from requirements in requirements quality analyzer, right? So I will just connect again to the same project, so that I can be now analyzing all the requirements that I have just gathered from the document. I connect again. Now these are the over 1,000 requirements that I have, or the tool has identified automatically from the document. Now coming from doors. Now remember that the tool is not connecting to the document. Now the tool is connecting to doors, where all these requirements are now stored. And here is the quality checking for all these requirements. So the idea is that now I will change the set of rules that I am applying, in order not to check the quality of these requirements, but to proceed with the clustering of the requirements. So once I change the configuration, I have to analyze the quality again. In this case, it is not analyzing the quality. Indeed, it is performing the clustering. It takes some seconds to cluster all these number of requirements. Okay, we are done. And now the idea is that here you can very quickly see that I have created just 3 different clusters. I am using a cluster based on keywords, just to put together 23 requirements dealing with wheels, 13 dealing with acceleration, 12 dealing with brake, and some others dealing with different measurement units, miles per hour or kilometers per hour, or propulsion or whatever, right? So we can put all these 88 requirements together and just to be allocated to the propulsion team. In this case, I am just using for this clustering, I have just used a set of keywords and a semantic cluster in our dictionary. For the second clustering, I am using a kind of much more advanced process. In this, for this clustering, I have used some keywords clustering, as I did before. However, we have identified also some clusters based on patterns. So this is just the small document, but these are the requirements that are following the patterns that I have identified to represent what is the structural part of a requirement. So in this requirement, it is said something like each vehicle shall have a minimum of a number of different passenger seats. So this is describing what is the structural, what are the structural parts of the requirements. So by means of just matching or fitting into one of the pattern that I have created for this clustering. In this case, it is just the noun plus shall plus have pattern. Then it is very quick to identify which are all the different requirements fitting with this pattern, so that now we can have all these requirements grouped together or clustered together, right? And then the final topic that I was addressing in this presentation is the link between the needs coming from one document with the requirements that we already have for our system. I have to say that this is the most challenging topic, mainly because you need a very well created ontology just to identify concepts described in different ways, as I was describing in my slide, right? So now I have to I will change to another document, right? So no, sorry, I can show you the completeness here for this auto tag document. Sorry, let me check where are my completeness rules. Are not here. Sorry, they are in the other document. So the idea is that you can very quickly adapt RQA just to analyze the completeness. Where what I have done is I have created here in Knowledge Manager. I have come up with a brief identification of kind of a product breakdown structure for this light vehicle. So these are the key parts of this vehicle in our system. So that what I want to know now is out of all these elements in my product breakdown structure, I want to know which ones are described or covered in the document coming from the buyer, and which are not covered by the buyer, right? So that we can have a better understanding on what are the differences between what we already have and what is coming from the buyer, right? So I have different. Sorry, I believe that I am connecting to the wrong project. I have two projects, and I believe that I am not connecting to the right one. So exit project. The semantic indexing of the requirements is already done, so that I don't have to repeat all the semantic indexing because it takes too long for these over 1,000 requirements. So this is why I have two different DOS projects. For one of these, this information is already calculated, the indexing. For the other one, I am doing everything on the fly, in real time. So I believe that I have connected to the wrong one previously. Now let me check. So these are my requirements now, and then I just change into a different set of rules, in this case just to analyze the completeness, which is just to know if out of the different elements that I have in my product breakdown structure, all of them or part of them are already described in this document. So I analyze the quality again. It is not now. It is not to identify the quality of individual requirements. This is already done, but rather to find the gaps between what we have and what is coming in the spec in the document from the buyer. I can see that now it is taking too much, probably longer than expected. So I have analyzed this several times, and every time it was faster. I don't know why it is now so slow. as I said, the tool is now analyzing all the keywords in this document and checking all these keywords with the product data structure that I was showing before, right? So that if I change into the completeness section of the tool, we can very quickly understand and see what are the elements from the dictionary that are in the PBS here in Knowledge Manager that are not fully covered in the spec coming from the buyer. So we know that this is representing what we know, this product data structure, and this document or DOORS document is representing what is coming from the buyer. So now we know that the buyer is not interested in an entertainment system, for instance. Remember that this is just a small section of the entire document, so probably the buyer is interested in this system, but since I just pick a small section, then the tool is just identifying what are the system elements that are not fully covered in the document from the buyer. And then I am running out of time, so the final block that I wanted to show you is the link between the requirements coming from the buyer and the requirements that we already have for our system. So this overlapping task is taking too long for our semantic indexing process. So I am now connecting to a second DOORS project where this activity has been already performed earlier, so that you don't have to wait probably 5 minutes or even more just to analyze the overlapping between these over 1,000 requirements. So now, if you just connect to your project, the tool is now retrieving all the requirements from DOORS. And the idea is that in this configuration, I have also implemented what in our tool is called a missing link metric. So what I have done in DOORS is for this module, I have created a link module called needs coverage, linking the requirements coming from the buyer, as was extracted in the automatic tool, with the requirements that we already have in our system, right? And now I have performed a task in Requirements Quality Analyzer just to identify, by using the semantic graph that I was describing before, we have identified which requirements on the one side are close or similar or having a similar meaning as the requirements that we already have for our system. So if we just check them, if we just check the content, so I am here. No, I don't want to perform the metric. I just want to check the results. So now the tool is going to show us what are the requirements on the one side that are fully covered with requirements on the other side. So if you just move here, then you can find requirements in these two tables. You just find requirements on one of the documents, in the documents coming from the customer, with similar requirements coming from our system specification. So we can find that just as an example, the requirement, the inside of steel shall be primed and printed with white paint is somehow matching or fitting into the requirement that we have in our system, saying steel components shall be treated to minimize corrosion. So we think that the tool is trying to link together the white painting with the minimizing corrosion, right? So this is the kind of linking that the tool is doing based on the information coming from the ontology. As I said before, the more information you provide in the ontology, the more of this advanced linking you will have for your requirements, right? And this is everything I wanted to show. Now we have 5 minutes for questions answer section. So the first question is, I would like to know how did you generate all the pattern you used? Oh, good question. Today, in the current version that we have in the market, the creation of the patterns has to be done manually. fully manually. When you install our tool out of the box, the tool already provides a number of different patterns, but if you need to tailor a little bit these patterns, you have to do it by hand. Or if you want to create new patterns, you have to do it by hand. The good news is that in the following version, we are implementing a very nice tool which is capable of taking, for instance, the same document that I have been showing before and extracting, by using artificial intelligence, extracting what could be a set of different patterns just to fit a percentage of the sentences in this document. So that probably there is still a kind of manual action just to tailor a little bit the result or to have a more accurate set of patterns, but at least the first set of patterns can be created in a very automatic way. Okay, so it seems that there are no more questions. So thank you for attending this webinar. As I told you, you will very soon have an email with the link for the recording of this webinar as well as the slides. Thank you very much. Please stay tuned and see you next time. Bye.